Hello, everyone. Thank you so much for joining us. We are going to get started right away. We have a lot to get through in the next hour or so. Today, we're going to be talking about Morningstar solar charge controllers and inverters for off-grid systems. My name is Michael Sherman. I'm a customer success rep with Morningstar. Joining me today is Roy Butler, who's a part of our technical support team. And Roy will be on hand to help answer your questions at the end of the webinar. Now, if you do have any questions during the presentation, please feel free to type them into the chat box located at the bottom of the GoToWebinar window, and we'll address as many as we can at the end of the presentation. Now, we will be recording this broadcast and emailing you a link to the recording before the end of the day tomorrow. We've also included the slide deck in the handout section of the GoToWebinar pane, so you can download it at any time during the presentation. Now, this presentation is meant to be introductory to off-grid solar and our products. For anyone interested, we also have multiple pre-recorded webinars available on our website that go into greater detail on things like system design, load control, system monitoring, and various other topics. You can find those under the resources tab on our site. All right, let's take a look at the agenda for today. So I'll start off with a brief intro about Morningstar and an overview of solar controllers and inverters. Then I'll cover PWM versus MPPT controllers. We'll go over efficiency and oversizing. We'll give you some examples of our products, and we'll have about 10 to 15 minutes or so for Q&A at the very end. So let me start by sharing a little information about Morningstar. Morningstar is a US company that conducts business through authorized distributors and dealers all over the world. Since 1993, we have been a leading supplier of solar charge controllers and inverters. We're considered to be the charging experts, and we've sold over 4 million controllers and inverters for all types of industrial, mobile, and residential off-grid applications. Morningstar has three product series. Starting in the middle of this slide, our professional series contains products that are offered globally. Many of the professional series controllers have communications and data logging capabilities, as well as special certifications that are not found in other charge controllers. The Essential series on the left is a line of Morningstar controllers based on the professional series, but with features catering to smaller residential or recreational projects rather than industrial and commercial systems that might require those special certifications or data communication capabilities. It provides access to Morningstar quality and technology in more price-sensitive projects. Now, it is important to note that the Essential series is not offered in the US or Canada. And then lastly, on the right is our integrated series, which is our new GenStar MPPT. Our GenStar MPPT controllers have the most robust features for communications and managing multiple loads. The built-in ReadyRail system also makes it very easy to add modules that enable relay, BMS, and shunt functions. In addition to our product series, Morningstar also offers applied services to industrial, commercial, government, and NGO customers that want to do any of the following. Uh, Embed or integrate Morningstar products or sub-assemblies into their existing products or new products. Contract with Morningstar and our partners to create a complete solution for off-grid power, charging, load management, and data integration, or private label our products. Now, again, these applied services are available to industrial, commercial, government, and NGOs, but not to personal consumers. The off-grid power applications that use Morningstar controllers are remote sites that are not connected to the electric grid. There's no utility company involved, and all power has to be generated by a system at the remote site. So why off-grid? Well, the main reason why people build off-grid systems rather than connecting to the electric grid at a remote site is usually predicated on cost. It costs approximately $50,000 per mile of wire to connect to the grid, and I think that estimate's actually quite a bit low. And this cost can be higher if there's difficult terrain involved, such as mountains, rivers, or forests. There are different sources of off-grid power. For high power needs, systems using fuel generators are often a good option. One problem with this, however, is the cost of fuel and the cost to transport fuel to the site. Another problem is the CO2 emissions. Wind and hydro systems are often considered as well, but not all remote areas have consistent or adequate wind and hydro sources. And fuel cells can also be used in some cases. But if the power needs are not too high, such as in the applications we'll see on the next slide, solar is an excellent source of power. In places that experience a limited amount of sunshine, hybrid systems that combine solar, wind, hydro, or even fuel cells can also be used. Now on this slide are some examples of off-grid solar applications where our charge controllers are used. In addition to residential and mobile home systems, Morningstar products are used in industrial applications at remote oil and gas sites, telecommunication sites, for remote monitoring, traffic, lighting, and railroad. These applications differ from the grid-tied systems that most people are used to seeing in neighborhoods, where the homeowners are selling back power to the utility company. Likewise, the solar panels and systems that you could see on top of, say, a stadium are also generally connected to the grid. So these are not the same as the off-grid applications where Morningstar products are used. With that said, let's quickly review the major purpose and functionality of a solar charge controller. So the solar charge controller, what does it do specifically? Charge controller maintains the battery at its highest state of charge while protecting the battery from overcharge by the array. Some controllers include load control for low voltage disconnect to protect the batteries from over discharge. In addition, they can offer lighting control to turn lights on during the evening and off during the day. Charge controllers can also provide system status indicators with meters and LEDs to display battery voltages, current, system operating temps, or other alerts. Additionally, some controllers also include data logging, as well as communications and monitoring capabilities via Modbus or SNMP protocols. Now, the charge controller generally represents about 10% of your total system costs. A good controller will extend battery life, and batteries can be 40% of your first-time cost and about 80% of your lifetime costs. Conversely, a poor controller can cause battery failure and even complete failure within your entire solar power system. Reliable charging to maintain battery health and extend battery life is affected by the quality of the electronic components that make up the controller, and more importantly, how well and how fast the controller software controls the electronic component hardware. Battery and PV voltage and current can change in split seconds, and the power electronics have to be able to respond fast enough. Now, most people don't see these dramatic swings going on within their controllers and inverters because you don't have the scopes and the monitors that you need to be able to see it. But for those of us who do have those scopes and monitors, we can tell which controllers are going to have the best effect on battery life. Now, I know this sounds very salesy, but you can have the best batteries and the best modules in the world, but they're only as reliable as your controller. All right, moving on. To give you a better idea how a charge controller fits into an off-grid system, let's take a look at a wire diagram that illustrates connections and power flow. So this diagram displays the Morningstar controller and other components of an off-grid system and how they are connected to power a direct current or DC load, such as the light in our example. So sunlight contacts the solar modules, which convert solar into DC electrical power that it delivers to a charge controller. Charge controller regulates the amperage and voltage that is delivered to the loads, and any excess power is delivered to the battery system so the batteries maintain their state of charge without getting overcharged. During the evening, when there is no sunlight, battery power would be used to power the load. Now you'll notice that the battery is grounded at the negative battery terminal, and this is because all of our controllers have a common negative ground. So it's possible to establish a common negative ground for the entire system, the solar array, the battery, and the load. And this meets NEC code requirements for grounding. Now, it's also important to note that Morningstar controllers can also be used in positive ground applications as long as proper guidance is followed. And I would generally recommend, if you have a positively grounded system, that you contact us for more information so that we can make sure that your system is going to work properly and correctly. To better illustrate the power flow, we ghosted out the charge controller on this slide. This example shows shows power flow during the daytime when the PV module is delivering power to the loads and the battery. And here's an example of power flow during the daytime when the load power draw exceeds the power supplied by the PV modules. So the battery is also delivering power to the loads. And this could happen during cloudy periods of the day or during the early morning or late evening time frames. In this example, the load is turned off and the PV module is delivering power to the battery only and not the load. And then lastly, this diagram shows power flow during the evening when there is no power being supplied by the sun, so the battery alone is running the load. Now, as a reminder, all these power flow diagrams that we just looked at relate to DC power, but on the next slide, we're going to take a look at a diagram that relates to loads that run off of alternating current or AC power. This diagram with an AC load looks very similar to the previous example with a DC load, except that in this example, we've added an inverter to the system. The purpose of the inverter is to convert the DC power from the battery to AC power that can be used to run an AC load like the TV in our example. Now you may have noticed that we are connecting the inverter from the battery, not the controller's load terminals like we did in the DC load example. And that's because the inverter can have a high energy surge on startup, and this high current surge might be higher than the rated capacity of the charge controller. Whereas the batteries, they'll be able to meet the high energy surge requirement. When installing a controller, this is very important. You want to connect the battery to the controller first, then you want to connect the load to the controller, and lastly, you connect the PV array. And when disconnecting, you just reverse that order. The battery provides power to the controller, so you always want to make sure that the solar and loads are disconnected before connecting or disconnecting the battery from the controller. And this, of course, applies to all Morningstar controllers. This graphic illustrates the Morningstar controller's multi-stage battery charging process. The first stage is bulk charging, delivering 100% of available solar power to bring the battery up to a state of charge of approximately 80 to 90%. When the battery reaches the absorption voltage set point, constant voltage regulation is applied. This prevents heating and excessive battery gassing while the battery approaches a full state of charge. During the absorption stage, the charge current reduces as it requires less power to maintain the regulation voltage. When absorption charging is complete, the battery has about 98% state of charge. Then the charging current is reduced further, so the battery voltage drops down to the float voltage. And the float stage keeps the battery at maximum capacity throughout the day. For flooded open vent batteries, an equalization charge is applied once every 2 to 4 weeks to maintain consistent specific gravities amongst the individual battery cells. The more deeply a battery is discharged on a daily basis, the more often equalization charging is required. Now, it's important to note that equalization is for flooded, not for sealed, gel, or valve regulated batteries, which can be damaged by equalization. It's also very important to note that this slide pertains to lead acid batteries only. Other battery chemistries can have very different charging requirements. Now, although lead acid batteries are still the most common type of battery used in off-grid solar systems, lithium and other battery chemistries are starting to gain traction. There's actually a very big market for lithium batteries these days. If you haven't charged lithium batteries before, we do need to let you know that you will need to deploy a battery management system, or BMS for short, and we strongly advise that you consult someone with experience and expertise that can review your system design and charge settings to make sure that you don't damage your batteries. On the right side of the screen is our Energy Storage Partner Program. Our ESP program is meant to take some of the burden off of our customers when using lithium batteries. We've been working directly with multiple lithium battery manufacturers to determine the best charge settings for each brand of battery. These charge settings will help to maintain the highest state of charge for these batteries and, as always, help maximize the battery life. And here is a screenshot of our website. You can access our free integration guides for all of our included manufacturers via the link in blue at the bottom of this slide, or you can click on the resources tab of our website and then click on Energy Storage Partner Program. Once you do that, you just complete a simple form and you can download as many guides as you want. The integration guides provide the custom settings information that you'll need to charge your batteries safely and again, to maintain healthy and long-lasting batteries. And here is an example of an integration guide. So we provide an overview of the lithium battery brand and the optimal controller settings that you want to adjust to concerning absorption voltage and battery high voltage disconnect and reconnect set points. We also provide battery current limits and any other optional recommended settings in addition to pre-made configuration files. So there's a lot of good information on the Energy Storage Partner Program webpage. And if you are using lithium batteries or even thinking about using lithium batteries, I highly recommend that you visit our website, take a look at our ESP program, and see if any of our integration guides could be of value to you. Now, here are some things to consider when deciding to use lithium or lead acid batteries. For lithium batteries, if a battery management system, or again, BMS for short, isn't included with the battery, you will need one. A BMS is an electronic system for balancing and protecting the battery cells. Lithium batteries will generally be advantageous in terms of weight, cycle life, depth of discharge, round trip efficiency, partial state of charge, energy density, and maximum allowable charge and discharge rates. Lead acid, on the other hand, is advantageous in terms of temperature tolerance, in particular with cold temperatures. And also lead acid should be easier to recycle and will generally have a lower upfront cost. And then lastly, since people have been using lead acid for a very long time in off-grid applications, these batteries might be more familiar and easy to use. Okay, in addition to lead acid and lithium, you can see nickel and other chemistries on this slide that can also be accommodated by our controllers. All right, moving on, let's take a look at the two major types of solar charge controllers. The two major types of solar charge controllers that Morningstar offers are pulse width modulation, or PWM, and maximum power point tracking, or MPPT. Now, it's important to note that both of these types of controllers are of equal quality. PWM controllers operate at battery voltage. One key aspect of PWM controllers is that they require matching nominal voltage panels as the battery voltage. So for example, if you have a 12 volt nominal battery, you should use a 36 cell module, which is a 12 volt nominal array. And of course, the controller needs to be able to charge 12 volt batteries. For a 24 volt battery, you should use a 72 cell module or two 36 cell modules in series. And then for 48 volt batteries, you can use two 72 or four 36 cell modules in series. PWM controllers are less expensive and they work very well in locations where there is consistent and abundant sunshine and where economics favor installing more panels instead of more costly balance of system components. MPPT controllers, on the other hand, operate at maximum power voltage, or VMP, which is higher than the battery voltage. The controller converts the incoming high VMP down to the battery voltage to charge the battery. And because they can step down the incoming high voltage, MPPT controllers have fewer module restrictions compared to PWMs. So for example, they can be used with 60 cell modules, which are often unsuitable for PWM controllers. A 60 cell module is basically the equivalent of an 18 or even 20 volt nominal panel. So all at once, it's too big to be used with a PWM and 12 volt batteries and too small to be used with 24 volt batteries. But with an MPPT, you can safely use them with 12 volt batteries or wire them in series for 12 volt, 24 volt, or 48 volt batteries. Now, MPPT controllers are ideal in intermittent sun and cloudy conditions and in cold weather where they boost module output more than in warm weather. And here's how to access information to help you choose the right PWM, or MPPT. So just click on products in the top menu of the MorningstarCorp.com website, and then click on Solar Charge Controllers. If you're looking for basic information concerning PWM controllers, just choose PWM under Technology, and you'll see all of our PWM controllers. You can filter further by battery voltage, charge current ratings, and professional or essential series. For more detailed information about dimensions, certifications, protections, maximum solar inputs, operating temperatures, model numbers, and a whole lot more, just click on any of the displayed products and check out the webpage content, as well as the data sheets, operation manuals, and any videos we might have. Now, if you're looking for an MPPT controller, just click on MPPT under Technology, and you can again filter the results by battery voltage and charge rating. So here are some common characteristics of our solar charge controllers. All Morningstar controllers in our professional series and integrated series have a 5-year warranty. Essential series controllers have a 2-year warranty. We are supported by select wholesale distributors. Many of them have been with us for a very long time. Also, our controllers are manufactured in a certified ISO 9001 facility and always subjected to very strict quality control guidelines. Now, Morningstar controllers are passively cooled and have no fans or moving parts that can often be a point of failure. This also keeps dust away from the circuit boards. Our controllers perform well through a wide range of temperatures from well below freezing to well above room temp, and they all have lightning and transient surge protection. Morningstar controllers are easy to integrate with all types of solar modules, batteries, inverters, and other balance of system components. With factory presets or saved custom settings, you can basically set it and forget it. Environmental protections associated with Morningstar controllers include epoxy encapsulation and conformal coating. So to illustrate the point about epoxy encapsulation, I'm going to use an example of our Sun Saver controller here. In the picture that you see now, obviously the cover is on the controller, but I'm going to show you a second picture with the cover off so that you can see the epoxy underneath. This epoxy protection is like hard plastic that completely covers and isolates all the electrical components and the PC board. This protects against humidity and airborne particles, and it's a best practice for electrical device manufacturing. Many controller brands don't have this protection, but Morningstar controllers do. Conformal coating is applied by a spray that goes over the circuit boards to protect against dampness and corrosion. The nozzle that you see here sprays a fine mist of epoxy or silicone coating. It travels up and down and all across to coat the entire circuit board to apply a coating that will provide additional protection against moisture, dust, and other contaminants. We also use surface mount components that are precisely assembled by machine, not by hand. So this makes for a very reliable, high quality product. Several Morningstar controllers are rated for use in hazardous locations where flammable chemicals may be present, such as acetylene, hydrogen, gasoline, acetone, benzene, propane, and methane. Our SunSaver PWM and SunKeeper controllers have been rated for use in Class 1 Division 2, Groups A through D locations for several decades, but now our ProStar MPPT, ProStar Gen 3 PWM, and SunSaver MPPT are also rated for such use, and they carry the North American, European, and international HAZLOC markings. This is a major development for those involved with off-grid oil and gas, mining, chemical processing, and environmental cleanup operations that require charge controllers with HAZLOC ratings and higher output power requirements. All right, moving on. Next, we're going to take a look at how the efficiency of a Morningstar controller varies at different power output levels. So efficiency is a ratio of controller output power to input power from the PV array. Or another way of looking at it is how much power is lost by the controller in the form of heat because of inefficiencies. You can see how on this MPPT controller graph of efficiency versus output power, the Morningstar controller, represented by the orange line on top, provides significantly higher efficiency at both low and high output power levels. Whereas The other controller's efficiency, represented by the blue line, drops off dramatically at output power levels away from its peak efficiency. You can see how the Morningstar controller reaches near peak efficiency very quickly and remains at high efficiency throughout virtually all power levels on the graph. Other MPPT brands have been shown to have more than 2 times the energy losses at higher output power levels. So when a manufacturer quotes you a conversion efficiency for a controller, you need to know the output power at which that efficiency was calculated and how much that efficiency will vary at higher output power levels. In a grid-tied system, a 0.25% difference in efficiency is a big deal, and we're talking about 1 to 3% here. So it's important for a charge controller to have high efficiency throughout low, medium, and high output power levels. Also, to help you appreciate what might otherwise be perceived as a small difference, I mean, I get it, 99 and 98 sound awfully similar, but when you're talking about efficiency and power loss in the form of heat, it really is a big difference. Another way to look at this is twice as much energy is being lost in the form of heat in the 98% scenario. All right, so let me close on efficiency and move on to the next topic, and that is oversizing arrays with Morningstar MPPT controllers. Now, it's important to note that the point I am making here about array oversizing only applies to our MPPT controllers. It does not apply to our PWMs. Now, I'm going to use our SunSaver MPPT as our example, but oversizing applies to all of our MPPT controller families. So in this example, the SunSaver MPPT has a nominal maximum operating power of 200 watts when used with 12-volt batteries, but using a 240 watt module won't damage the controller and won't cause it to exceed its rated 15 amps of output current. Now you do need to bear in mind that you do still have to adhere to all the other operating guidelines that are listed in the operations manual. So for example, you can't exceed the open circuit voltage limits of the controller because that would damage the controller. And on the next slide, we'll take a look at a graphical view of what's going on in this example so you can see the benefits of oversizing and why you would want to do this. But before we do that, I did want to point out that you can also read more about array oversizing in a white paper that's available at the link at the bottom of this slide or under the resources tab on our website. So we're going to create a graph of operating power versus time of day for the SunSaver MPPT, which again has a maximum operating power rating of 200 watts when used with 12-volt batteries. So here we are comparing the performance of a 200 watt module, represented by the black curved line, to that of a larger 240 watt module, represented by the blue line. Now, this is an operation on a clear, sunny day at standard test conditions and maximum power. When using the larger 240 watt module, even though the power being delivered to the battery is limited to 200 watts, and the red area at the top of the production curve represents lost power, the larger 240 watt module is still harvesting more energy than the smaller 200 watt module, which is going to be shown here in green. The larger module will provide better production with no power shaving early and late in the day compared to the smaller module. And in this case, almost twice as much energy is gained, that's the green area, than what's lost, that's the red area. And you get 12.5% more energy available to charge your batteries than you would with the smaller 200 watt module. All right, now that's perfect conditions. So what happens on days when it isn't clear and sunny? This graph, using real array data to depict what happens on days with intermittent sun and clouds for, again, the 200 watt and the 240 watt module. On these days, there's going to be little to no power shaving, and the extra power will serve the battery well with more energy harvest. On this day, for the larger 240 watt module, there is less than 1% lost due to power shaving. That's anything above the red line. So almost all of the excess power compared to the smaller 200 watt module can be utilized for charging. So basically, to sum up, systems that experience a lot of intermittent sun and shading during the day are very good candidates for oversized arrays. All right, next let's take a deep dive into our newest controller, and that is our GenStar MPPT. So here is our new GenStar MPPT. It's important to note that we have several pre-recorded webinars on our website that are specifically dedicated to our GenStar MPPT, but I do want to take a few minutes to provide a few highlights about this controller. So this controller comes in 60, 80, and 100 amp models with a maximum VOC rating of 200 volts to charge 12, 24, and 48 volt batteries. It has extensive load control capabilities. It also has special capabilities including wireless Bluetooth communications and SNMP support. And then lastly, it has relay, BMS, and state of charge calculation capabilities that can be added with our Ready Block accessories. Here's a cutaway that shows some of the internal components. As I mentioned on the last slide, our GenStar MPPTs are compatible with our new Ready Block accessories, including the Ready Relay, Ready Shunt, and the Ready BMS. These blocks are inserted into the Ready rail to enable generator starts and stops, state of charge calculations, and lithium battery management. And here are photos of each Ready block. The green Ready BMS enables full communications and control with a growing list of lithium batteries. The blue Ready Shunt provides state of charge calculations for all battery chemistries. And the Ready Relay provides advanced load control to start and stop generators and fuel cell power sources. Now this slide shows how our new GenStar MPPT combined with our Ready blocks provides 7 component functionalities including Ethernet SNMP interface, battery monitoring, lithium BMS interface, charge control, all the networking capabilities of our meter hub accessory, external load control including low voltage disconnect, and relay and dry contact control and logic to start and stop generators and other external power sources. On this slide, I wanted to point out that the latest firmware update for GenStar MPPT enables support for SNMP, HTTP, and Modbus protocols. As I mentioned earlier, our GenStar also has wireless Bluetooth for Android and iOS mobile apps. These apps allow you to connect to Morningstar's LiveView 2.0 browser interface to help you monitor, program, and control many of the components of your off-grid system. Now this is very important. In order to enable GenStar MPPT and any installed Ready blocks to provide all of these capabilities that we've been seeing on the last few slides, you do need to install the latest firmware. You can install the firmware by going to the GenStar MPPT product page on our website and then clicking on firmware in the resources section. To demo LiveView 2.0 or to connect your GenStar to it, you just click on the link under the resources section on the GenStar product page. And this slide gives you a glimpse of what the LiveView 2.0 dashboard looks like. LiveView is very extensive. It provides PV array, battery, charge controller, and load metrics. It enables various commands to the controller, data logging, settings adjustments, and the firmware updates that I just mentioned on the last slide. And again, you can demo the LiveView 2.0 dashboard at any time by going to liveview.morningstarcorp.com. We also have multiple videos available that go into much greater detail, and you can learn more about the LiveView 2.0 app at the link on the screen here or under the software section of our website. Okay, so to sum up about the GenStar MPPT, it answers the call of integrators, installers, and system designers looking for more capable and feature-rich solar controllers. It reduces total system footprint by eliminating multiple external accessories. It avoids extra communication cabling, addressing, and software setup. It reduces installation labor while improving reliability, and functionality can be expanded or further customized depending on the needs. All right, that was definitely a deep dive. Catch my breath here a little bit and move on to the next topic. So in addition to controllers, Morningstar offers inverters and accessories, and we're going to take a look at those on the next few slides. So here are our new SureSine Pure Sine Wave off-grid inverters that we launched a few years ago. They convert DC power to AC power and are designed for use in a wide variety of industrial, commercial, residential, and mobile applications where no grid power is involved. Now, many of our customers have been asking us to build inverters that support 24 and 48 volt batteries, in addition to the 12 volt batteries that we could before. And now we offer models that are rated for each of those battery types, and the power output includes 150, 300, 700, 1000, 1250, and 2500 watt models. These units meet North American and international certifications, voltage and frequency specs. SureSigns can use Bluetooth or manual dip switches to customize the settings. These inverters have status LEDs to provide notifications about system alerts and to ensure reliable operation. All of these new SureSigns have a passive thermal heatsink to dissipate heat without the use of fans. Fans are a parasitic load and they do draw in dust and debris to the unit, and they are usually subject to just equipment failure. And then lastly, it's important to point out that these new SureSigns have adjustable low voltage disconnect. Many other brands don't have low voltage disconnect, or if they do, it's not adjustable. A number of our customers have indicated that the ability to modify the LVD settings is a must-have feature for them. And here you can see our classic SureSign off-grid inverter. This inverter was first introduced in 2006. Just like our new SureSigns, it's ideal for rural electrification, telecom, mobile, and marine installations that require AC power. It has a low self-consumption of 450 milliamps when powering loads. During no load conditions, the SureSign automatically powers down to standby mode, and self-consumption is reduced to 10% of operating consumption. It's available at 115 volts at 60 hertz or 220 at 50 hertz. It provides 300 watts of continuous power and 600 watt surge, which is peak power rating for up to 10 minutes. The SureSign has a 12 volt input, it's highly reliable, and it's equipped with an environmentally ruggedized chassis design. Now this slide displays the website page for our Ready Rail products and accessories. The Ready BMS, Ready Shunt, and Ready Relay that you see in the upper right support our new GenStar MPPT. And our other accessories include a ground fault protection device, optional meters, communication adapters, and remote temperature sensors. Each of our accessories has a page on our website and lists compatible Morningstar products. Vice versa, each of our product pages also lists compatible accessories. So you should be able to quickly see which accessories work with which products just by going to the website. What you see on this slide is our Ethernet meter bus converter accessory, or EMC-1. It converts a serial connection to an Ethernet connection, enabling compatible Morningstar products to be connected to an IP network and the internet to facilitate remote monitoring and remote system settings adjustments from really anywhere in the world. It's compatible with all of our professional series MPPT controllers, as well as our TriStar PWM, ProStar Gen 3, SunSaver Duo, and our classic SureSign. You can see in this diagram how connections are made with the RJ11 cord between the Morningstar product on the right and the EMC1 in the middle. The EMC1 is connected to an Ethernet gateway, which is typically a router or a switch that you can see on the left. So for example, many of you might have legacy Morningstar products that up until now could not connect to an IP network or the internet. But now if you connect the Morningstar controller or inverter to the EMC, you can view remotely in your web browser things like battery voltage, PV current, load current, or faults and errors in the system. This information will appear live in real time, so you'll see data changing without having to refresh your browser. Furthermore, you can use our free MSView software with the EMC so that you can change your battery charge settings, low voltage disconnect settings, and lighting settings. Every product in MSView has its own setup wizard for adjusting these settings. And to make it easier to use the MSView setup wizards, we've also created a web page that lets you download pre-made custom setting configuration files. So if you click on the resources tab on our website and then click custom settings in the dropdown, you'll be able to access a page that contains links to product factory preset configuration files for all of our applicable controllers. Now, you might only have to change a few settings on the configuration file to match the requirements of the battery brand and type that you're using. So these preset configuration files can save you a lot of time versus having to do everything yourself and enter those values manually. We also have another useful tool on our website, and that is our string calculator. I know that I'm personally on this tool just about every day. This calculator lets you know how many modules you can range in series and parallel for a given type of module, battery system, and Morningstar charge controller. Now, I always recommend using this tool to make sure that your panels will be compatible with our controller. And to find it on our website is pretty easy. There's a link here. There's a link under the products tab, or you can type string into the search bar. And then lastly, we've recently launched an online Morningstar community for distributors, installers, customers, partners, and really just everybody. Everyone is invited to sign up and become a community member to access information, participate in forums, and share photos of your applications. You can access and become a community member by clicking on support on our website and then clicking on online community. All right, in summary, all charge controllers are not equal. Amperage and voltage ratings differ, and charging algorithms and advanced features and protections will vary amongst different products and brands. Charge controllers provide core functionality to solar power systems to maintain healthy and long-lasting batteries, and a failed controller can cause failure in your entire solar power system. For the last 30 years, actually more than that, last 31 years, Morningstar has been focusing on designing and providing high quality, reliable products for off-grid systems sold and supported through our global distributors. We've had the same ownership, management, and strategy since 1993, and many of our distribution partners have been with us for a very long time. And again, we rely on them to provide pricing information, service, and technical support for your entire solar power system. And for anyone who's listening, we are always happy to introduce you to one of our distributors, no matter where you are in the world. Our global distribution network covers virtually every country on the planet. And for those countries that we don't have anyone directly on site in country, we would have someone in the region that could still help you. And if you're interested, feel free, reach out to us. The easiest way is just to email sales@morningstarcorp.com or go through the website. And again, we would be happy to introduce you to a distributor that can help you with system design, product selection, and of course, purchasing. All right. With that, that is the end of the core presentation. Looks like I'm actually a minute, maybe even 2 minutes ahead of schedule. That's pretty good for me. I usually tend to run long. I'm going to bring on Roy Butler. Again, Roy is part of our technical support team. We are going to try to answer as many questions as we can in the time that we still have left. My apologies up front if we don't get to your questions. Sometimes we do get overwhelmed with the number of questions that come through. If we don't get to your question, we will respond back to you, typically by email over the next day or so. All right, Roy, I have not looked at the questions other than I saw them coming in. So if you want to take the reins, go ahead and I will catch up.
Thanks, Michael. Hi, everybody. Well, let's plug on through here and see what we have. So, Michael's asking for commercial systems, what is the typical production life? For example, how long will a product be manufactured? Well, that's a good question because we we've been making the Sun Saver for what I think since what 93, 94, and the Pro Stars for about that same length of time. And to the best of my knowledge, I don't know as we've had any products that have been discontinued. So for the most part, we just keep going with the same products, although we improve them over time, and we make changes, add features as the industry needs. So yeah, we're not going to introduce a product and then just have it be gone. So yeah,
Yeah,
feel comfortable in that regard that it's going to be around for some time.
yeah, I'll
Michael,
chip in on this one.
yep.
I'll chip in on this one. So the ProStar is the classic example. We are currently on generation 3. we even just today, I was talking to a customer that had an older generation 2, still functioning, still doing everything it's supposed to. Not too long ago, I actually had someone contact me with a generation 1, which dated back to 1996, I think, something like that.
And I've had that as
Still in the
well.
field. Yeah, still in the field, still working. Usually the generation spins are about um, feature sets are catching up to the market. So as an example, the current generation 3 of the ProStar added all of the customizable settings that we keep talking about through the presentation, plus the communication capabilities that we keep talking about. That was a big jump forward. But the controller itself at a functional level is very, very similar to the the previous generations. So much so that it actually has the same physical footprint. You can literally use the same drill holes with generation 2 or generation 3.
Right. It's definitely a drop-in replacement, no doubt. So Michael also asks, once a product is discontinued from manufacturing, how long will we continue to support it? Well, once we discontinue a product, I'll let you know. But seriously, there's a 5-year warranty, and even though you may not get it replaced under warranty 10 or 12, 15, 18 years from now, we will continue to support it. If you're having issues, we'll help you troubleshoot it and so forth. So um, we still stand behind the products regardless how long you have them. And
Yeah, I'm going to
Alan's,
put a plug in. I'm going
yep.
to hold on, Roy. I'm going to put a plug in for you and the
Okay.
team. I think very highly of our tech support team. I just want to be clear for everyone listening that we really do mean it when we say that we will support you. Obviously, there are limits. There's only so much that we can do, but it is always worth contacting us to see if there's something that we can do, especially with troubleshooting and obviously warranty if the controller is still within the 2 or 5 year warranty, depending on the model.
Right. Yep. So, well, thanks for the plug there. Alan asks, how many solar panel watts can be used for a 10 amp controller? My RV has a built-in 10 amp controller, and I'd like to add solar panels to my RV to charge a lead acid battery. Well, you can put 10 amps worth of solar on there. So what you would need to do would be to look at the nameplate on the solar panels and make sure that the short circuit current, the ISC is how it's usually stated on the label, they do not add up to more than 10 amps. And that would be probably somewhere about 130, 140 watts, give or take. It's going to depend on the panels themselves, but somewhat just over 100 watts would be a safe way to answer that question.
Yep, and check out the string calculator that we mentioned earlier. It's a really
Definitely.
nice tool for that. It I always laugh when I'm talking to customers because I'm doing the math in my head and then I immediately turn around and do it through the calculator just to be sure that I'm not missing something. It's really nice and color coded. It'll tell you in red numbers that you can't do it or green numbers that you can.
That's right. Yep. Very, very good tool. Michael also asks, what is the temperature range of operation? Most of our charge controllers are rated for minus 40C to a positive 60C. They will work somewhat outside that range, but we don't guarantee it. So the minus 40 to positive 60 is a given, and but we do have controllers that are running well outside that range. That's just not necessarily what we recommend.
Right.
So,
Maybe
Michael,
just a quick version of what happens when you start going outside the range. And it is worth noting that we have tested these things. We do have documentation for numerous examples of our controllers because of various applications that we deal with regularly. But just maybe a quick overview of what happens if you get too hot or too cold.
well, if you get too cold, electrolytic capacitors can freeze up. Other components begin to stop working properly, and microprocessors can begin to act strangely. So, if it gets too cold, you'll probably have unreliable operation, or it may just actually shut down. When it gets too hot, positive 60C, that is ambient temperature. The heatsink temperature is what the charge controller uses to decide when it's time to begin to cut back on the current production to lower the heat, internal heat. So usually you're looking at probably anywhere from 10 to 20 C higher inside the controller than the ambient temperature. That depends on how much current is being produced, if you've got it in a tight little box or out in the open, a lot of different variables. But heat will actually cause the charge controller to begin to back away, and eventually it will stop producing current altogether to protect itself. So, and that would be above the 60C.
Yep.
So
Yep.
yeah, a lot more questions rolling in here, so I want to keep on keeping on here. So Michael asks, what's the IP rating of commercial controllers? Well, all of our controllers need to be indoors. So I do know that some of them have a rating of IP10. So basically it's indoors and you've got to keep it away from moisture, active water, mist, etc. And
That could
here's one.
include an enclosure for,
Yes,
for
it
what it's
can
worth.
include an enclosure. Yeah, definitely. And at that point, the IP rating becomes moot. So, you're just looking at the proper enclosure at that point. Here's one for you, Michael. Who's your commercial executive in Mexico?
So this question is from Juan. Juan, I will reach out to you outside of this session and get you in touch with one of our distributors in Mexico. That is not a problem. We would just need to know what you're looking for. If you happen to know what products, what quantities, the usual type of information. But definitely, I'll reach out to you post webinar. Probably give me till tomorrow, I would think, and I'll reach out.
And here's another one here that I'm not sure I can answer. It's sort of half in my department and half in your department there that Michael asks. Can controllers be shipped configured for our specific product, or will we need to configure upon receipt at our factory? Um, yeah,
Uh,
typically, yeah,
yeah, do you want it
typically
or
they
should I?
would be configured by the end user typically.
Yeah, so my answer as part of the sales team is never say never. It would really depend on the specifics, the volume, what's entailed, a whole lot of details. Michael, this might be one that's just better for you and I to take offline, and we can see what possibilities there are for you.
Yeah, we're never going to get through all these questions. Wow, I can't believe how they're rolling in here. Do we have smart inverters? No, no, we do not. We have standalone, just basic inverters. So they're good inverters, but they're not very smart. So it's about the best I can answer on that one. Would your products handle a 300 kVA system? No, we don't have anything even remotely that in that range. We're down in the smaller range, well below 300 kVA. So, and let's see, how is the generator triggered with lithium batteries? As you know, that voltage level doesn't drop much compared to VRLA. Well, there are different ways you can trigger generator start. So you may be talking about the ready relay and the GenStar. You can trip that by state of charge if you're set up for that. You can trigger it on a timer. You can trigger it under different circumstances, but the voltage range on the lithium is still wide enough to trigger a generator because the granularity of the programming for the ready relays is such that you could even trigger it on a half a volt drop. But I mean, I think if you were to trigger it a volt and a half drop, that would be more than good enough. So you can still trigger it to start even on a lithium battery, even with that narrow voltage range that they have. So yeah, let's see. I'm still scrolling here. Let's see. Is there a rule of thumb regarding how much to oversize an array with an MPPT controller? And that's a good question. We get that in every webinar. Typically, on most of our charge controllers, our MPPT controllers, 30% is what we recommend. And you can go as high as 50% on the GenStar. Ultimately, it's your budget and your solar conditions. So if you're in the mist all the time, well, you could probably go quite a lot more than 30 or 50%. But just know you're never going to get more than the rating of the charge controller to the batteries. And that's a given. So at some point, the economics are going to come into play there. So between 30 and 50% is the average. That's the best I can answer on that one. So, and let's see. Yeah, we're getting so many in, I'm losing my place here. Well, this is good. So let's see. Uh,
Yeah, I'm kind of in the
Here we
same boat,
go.
trying to
Yeah.
trying to keep up.
Yep. We have an original ProStar and it's been working great for 20 years. Well, that's excellent, Kristen. That's really nice to hear. And I do hear that a lot too. You're in really good company there. Um, we've I installed a bunch back in the mid to late 90s and a lot of them are still working just fine. It's crazy. I mean, they are definitely a robust unit. So if I have to offset the grid power using solar at a telecom cell site operating at minus 48 volts, 10 kW load, what product should I use? Most of our charge controllers can be used in a negative ground system. And with a 10 kilowatt load, you're looking at a good size solar array. So you're probably looking at a few of the GenStar controllers. That's what I would say because we've got the 100 amp unit. But if you want to reach out, we have an applications engineer that could probably help you with the sizing on that. So
Yep, I was just thinking the same thing that I can reach out as well. Again, similar to what I was saying before, I can go into much greater detail post session because, like you said, we got a lot of questions.
yeah, yeah, yeah. Okay, here we go. Masood says it's observed that sometimes the breaker on MPPT trips. Can this be reset turned on remotely? Um, I'm not sure what you mean by what ALM is provided over Modbus when the breaker is tripped. If you trip the breaker on the unit, you're not going to get any Modbus from it. The one thing I would say is find out why the breaker is tripping to begin with. Now, a lot of people will, on an MPPT, they'll just put that rating of a breaker. For example, like a TriStar MPPT 60. They'll put a 60 amp breaker in. If you look in the manual, you realize that we actually advise you to oversize the breaker, 70, 80 amps. Make sure that your conductor is sized for that. But you're actually protecting the wire with the circuit breaker and not so much the charge controller. So, you could put a larger wire on there that can handle 80 amps and put an 80 amp breaker in. So I would do that um, because now and then, just for a split second, the MPPTs can put out just a tad more than what they're rated for. It's very quick, and it's not for long at all, but it's enough to trip the breaker. So I would oversize your breaker and make sure that your conductor is rated for that current of that breaker. Let's see what else we have here.
Let's
Okay, how many
see.
EMC1 converters are required per site if I have multiple MPPT? That's an easy one. You'll need an EMC1 for each charge controller because you can't put more than one controller on one EMC. They're a one device use only.
Yep.
So,
Having said that, this could be, and again, Masood, I apologize if I'm mispronouncing your name. We can get in contact post session, but this might be a better example for our new Gen Star MPPT because that has a lot of the same functionality, really all this functionality of an EMC built into the controller, and you wouldn't have to worry about accessories at all.
true. Well, even the TriStar MPPT 60 has the Ethernet connection too, so that's a possibility. It depends on the size of the system. But does the MPPT have any lightning protection? Well, there is surge protection in there. They are TVS diodes, but that's just very very basic. And we would encourage you to put a third party lightning protection on there, like the Midnight SPD, and there's several other commercial options out there. That's what I've got in all of my systems too, and that's the best advice that I can give you on that. So yeah, even though we have very basic protection, add some more. It never hurts to have it, and do that on the battery side and on the solar side of the charge controller, especially the solar side because that's a big antenna that'll pick up those surges. Let's see. Christian says, I have three 100 watt panels hooked to a 30 amp charge controller. Can I add more panels to address the low lighting scenario you had in the graph? If this is an MPPT controller, then yes, you can. And again, you're looking at three 100 watt panels. So you didn't give me an idea as to what the battery voltage is, so I can't really say for sure. But if it's at the higher range, like a 24 or a 48 volt battery, then you can definitely add more. If it's a 12 volt battery, you can probably add another 100 watt panel on that anyway. So that's seat of the pants type thing. Um, I would suggest you use, as Michael would say, and I'm sure he's champing at the bit to say this, and I'll steal his thunder. Try our string calculator, the solar string calculator on our the sizer on our website. That's the best way to look at it, and it'll tell you how much you're oversized too. So let's
And you beat
see.
me to it. Let's see. I saw one about form factor with new generations. Real quick on that one. So far, they've more or less stayed in the same form. I don't want to overpromise as we go forward because as things change, requirements might change. But to date, our Sun Savers are the same, the Pro Stars are the same. You get the idea. But who
Yep.
knows for future
Yep.
products?
There's one here from Rich. Do your products meet FCC, RFI, EMI specs? And they do. We go through all of that testing. And the yeah, that's usually stated in all of our. You can look up the under support and document search. You can find all the documents related to all of our controllers there on our website. And Michael asks, any controllers rated for outdoor use? We have two. We have one that's a little 4.5 amp SunGuard, and then we have the 6 amp and 12 amp Sunkeeper that are meant to actually tie into a solar junction box on the back of the panel. What would be the most ideal controller or inverter for large scale systems, dual axis trackers of 20 kilowatt each? Good question. You'd have to be in the Genstar range, the 100 amp Genstar range, I would say. Um,
Yeah,
yeah,
I
and
would
as
agree.
far as inverter, we don't have inverters for anything like that, but the controller we would be able to help you with.
Yeah, and I'll put a plug in that if you're not a solar designer yourself, I mean, this is a really good case of you should talk to one of our distributors that has a design team because they'll make sure that you get the right products and
Mm,
how to build larger systems can get complicated in a hurry.
yep. So the Morningstar work with PBS04. That's lead something or other, and lithium ion batteries. Um, Custom programming of our controllers allows us to work with just about any battery that's in existence. So I would say tentatively, yes. And if you've got a specific model that, don't ask it here. We won't have time to get into that here. But you can send a, um, Michael, would that be to you in sales, or you want them to go to
Yeah,
support?
either or, it'll get to the right place. But yeah,
Yeah, you can go to
um,
support at morningstarcorp.com, and we will either take care of it or we'll send it on over to the application engineer. Here's a good one here. What's the maximum conduit size for your GenStars? Um, we don't have conduit adapters for our GenStar. Our GenStar is really made for the commercial end of the things, and we do not have conduit entries on it. So every time I plug in my SunSaver MPPT battery, it sparks a bunch. Is there any inrush current limiting components on the battery input terminals? There are not. What you're seeing is inrush current as the capacitors that are inside the unit charge up. You're better off to have a circuit breaker or a switch in line. Go ahead and make the connection to the charge controller and then turn on the breaker or switch, and you will not have a spark. Why does the MPPT make noise when solar
I
power
love
is
how you
being?
just answered that so quickly. I didn't even know what the question was.
Sorry.
That's the difference between sales and support right there.
Yeah, I do this stuff in my sleep, or so I'm told. Why MPPT makes noise when the solar power is being produced? Because there's microprocessors in there, and the microprocessors work at varying frequencies, and so you will get some sound, and it will attenuate in the case just a little bit, and you will hear it. It's not really bad, but they do make sound. There's no doubt about it. And Kristen answered my other battery 12 volt. Yeah, Kristen. So my original thing still stands, where I would say maybe add another 100-watt panel. But again, check it out with the solar string sizer there, the calculator, and I think you'd be better off. And I think we got them all.
Yes, I was just gonna say that was a bit of a marathon. I know we ran a little bit long, but I'm glad we did it. If we did miss anybody, again, apologies. We will get back to you. And then for those handful of questions that I mentioned throughout the Q&A session that we should take offline, we will get back to you. So typically, you just got to give us a little bit of time. It takes a while to process all of the background information from these webinars, but we will get back to you with probably myself or Roy, depending on who's more applicable.
Yeah, and sorry for the rapidity of that. I was trying to squeeze 50 pounds of potatoes into a 20-pound sack there, but we got through it. So,
Yeah, agreed. So I think the only thing left, Roy, is for you and I to just say thank you. Thank you so much.
yep, thanks everyone, and have a great day.